Hey everyone, today I'm just going to be doing this basically worthless equation. I mean, this equation probably says applications, but the point is, this is near useless with what I'm trying to show. So we have x times y equals 2, and the whole point is, I guess, sort of to solve for x and y. So we're going to be sort of solving for x and y. The method I use is, well, useless. Doesn't tell you a whole lot. It doesn't give you an actual answer, but we're going to be doing it anyway because I don't have any other video ideas. So when I take the natural log on both sides, we get ln of x y is equal to ln of 2, and because of logarithm laws, I can split that up into ln of x plus ln of y, and this is equal to ln of 2. Now I'm going to subtract ln of y on both sides. This cancels out, and we get ln of x is equal to ln of 2 over y. Because of our logarithm laws, I'm just sort of combining them. Hey, you gotta finish that. There you go. Okay, now we're gonna take, well, we're gonna make both these base e, so we're gonna put e on either side, and this cancels out our log. And what we're left with is x is equal to 2 over y. Now, I'm just going to write this up here because it's kind of big, but since we have x is equal to 2 over y, I want to use the Lambert W function to solve for what x is. And what that states is that if we have some w of f of x, capital F this time, we just get x, because it's essentially the inverse function of whatever f of x is. Meaning, I think that's right, I don't know the exact thing, but essentially if we had some form x times e to the x, and we applied w to it, the Lambert W function to it, we are left with just x. And that's exactly what I want to do with x equals 2 over y. So what I'm going to do is I'm going to use x times e to both sides and use x times e as its base. So we have x e to the x is equal to x e to the 2 over y. Now, since we have this form, we can use the Lambert W function on both sides, and what we're left with is just x is equal to w of x times e to the 2 over y. Now, this means nothing because, well, Wolfram Alpha tells you no actual number. We get this indefinite integral, we get our global minima, we get some imaginary part contour lines, and we get that there is a root at x equals 0, so it touches the origin, but we don't actually get any numerical value for what x and y are equal to, because what I did is basically all useless, and anyone seeing this could say a bunch of solutions for x times y is equal to 2. There's probably a way smarter, way more intuitive way to say x times y is equal to 2 and actually use the Lambert W function for what it's for, but what I have just shown you is like probably the worst example of how you could use this function. Thank you for watching.